Chapter 1, Exercise 1.1. Question 1. Express each number as a product of its prime factors. Solution. Prime factorization is dividing a composite number repeatedly by the smallest possible prime numbers until the quotient is 1. First have 140. 140 divided by the smallest prime factor 2 and the quotient will be 70. 70 is divided by 2, then it will comes 35. 35 divided by the smallest prime number 5, the quotient will be 7. 7 divided by the smallest prime number 7 and the quotient will be 1. Now prime factors of 140, that will be 2 into 2 into 5 into 7, and that will be 2 square into 5 into 7. Next, 156. 156 is divided by the smallest prime number 2 and the quotient will be 78. 78 will be divided by 2, that will be 39, and 39 will be divided by the smallest prime number 3 and the quotient will be 13. 13 will be divided by prime number 13 and the quotient will be 1. Now prime factors of 156 equal to 2 into 2 into 3 into 13, that can be written as 2 square into 3 into 13. Now next question 3. 3825. 3825 divided by the smallest prime number 3 and the quotient will be 1275. 1275 divided by the smallest prime number 3 and the quotient will be 425. 425 divided by the smallest prime number 5 and the quotient will be 85. 85 divided by 5, the quotient will be 17. 17 is divided by the smallest prime number 17 and the quotient will be 1. Prime factors of 3825 equal to 3 into 3 into 5 into 5 into 70, that can be written as 3 square into 5 square into 17. Now 5005 5005 divided by 5 and the quotient will be 1001. 1001 divided by 7 and the quotient will be 143. 143 divided by 11, the quotient will be 13. 13 will be divided by 13, the quotient will be 1. Now 5005 prime factor of 5005, that is equal to 5 into 7 into 11 into 13. Next 7429. 7429 divided by 17 and the quotient will be 423. 423 divided by 19 and the quotient will be 23. 23 divided by 23 and the quotient will be 1. Prime factors of 7429 equal to 17 into 19 into 23. Next question, question 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into LCF equal to product of numbers. Solution. First, 26 and 91. Prime factors for 26 and 91 is 26 equal to 2 into 13 and 91, that is equal to 7 into 13. Now HCF is the common factors of two numbers, so 13 will be answer. LCM is multiplying the highest power of each prime factors present across the numbers, that is equal to 2 into 13 into 7, that will be 182. Now 13 into 182, that is equal to 26 into 91, that is equal to 2366 on both sides. Hence prove HCF into LCF equal to product of two numbers. Next, 510 and 92. Prime factors of 510 and 92 is 510, that is equal to 2 into 3 into 5 into 17. 92, that is equal to 2 into 2 into 23, that can be written as 2 square into 23. HCF is the common factor of two numbers, so 2. LCM is multiplying the highest power of each prime factors present across the numbers, that will be 2 square into 3 to the power 1 into 5 to the power 1 into 17 to the power 1 into 23 to the power 1, that is equal to 23460. Now multiplying 2 into 23460, that equal to 510 into 92, that will be 46920, that will be 46920. Hence prove HCF into LCM, that is equal to product of two numbers. Now next, 336 and 54. Prime factors of 336 and 54 is 336, that is equal to 2 into 2 into 2 into 2 into 3 into 7, that can be written as 2 to the power 4 into 3 to the power 1 into 7 to the power 1, 54. That is equal to 2 into 3 into 3 into 3, that can be written as 2 to the power 1 into 3 to the power 3. HCF is common factor of two numbers, so 2 into 3 equal to 6. LCM is multiplying the highest power of each prime factor present across the numbers, so 2 to the power 4 into 3 to the power 3 into 7, that will be 3024. Now multiplying 6 into 3024, that is equal to 336 into 54, that will be 18144, that is equal to 18144. Hence proved HCF into LCM equal to product of two numbers. Question 3. Find LCM and HCF of following integers using prime factorization method. Now first 12, 15 and 21. So prime factorization is dividing a composite number repeatedly by the smallest possible prime numbers until the quotient is 1. Now 12 को हम लोग स्मॉलेस्ट प्राइम नंबर 2 से डिवाइड करेंगे, क्वोशेंट विल बी 6 विल डिवाइडेड बाय द स्मॉलेस्ट प्राइम नंबर 2, क्वोशेंट विल बी 3 डिवाइडेड बाय इटसेल्फ एंड द क्वोशेंट विल बी 1. देयरफॉर प्राइम फैक्टर्स of 12, that is equal to 2 into 2 into 3, that will be 2 square into 3. Now second में 15 is divided by the smallest prime number 3 and the quotient will be 5 will be divided by 5 and the quotient will be 1. Therefore prime factors of 15, that is equal to 3 into 5. Next 21 is divided by the smallest prime number 3. The quotient will be 7 will be divided by the smallest prime number 7 and the quotient will be 1. Prime factors of 21 equal to 3 into 7. Now 12, 15 and 21 consist 2, 3, 5, 7 as a prime numbers. Now prime factors of 12 can be written as 2 into 2 into 3, 15 that is equal to 3 into 5, 21 that is equal to 3 into 7. 3 is common in 12, 15 and 21. Here 3 is a common factor in 12, 15, 21. So HCF will be 3. Now 2 has a maximum power of 2, 3 has a maximum power of 1, 5 has a maximum power of 1, 7 has a maximum power of 1. Hence LCM, that is equal to 2 to the power 2 into 3 to the power 1 into 5 to the power 1 into 7 to the power 1, that is equal to 420. Now question 2, 7, 23 and 29. Here 7, 23 and 29 are prime numbers, so no common factor other than 1. So HCF will be 1. Maximum power of all prime numbers consist in given numbers is 1. So LCM, that is equal to 17 into 23 into 29, that is equal to 11339. Now 8, 9 and 25. Prime factors of 8, 9, 25 is 1. 8 can be written as 2 into 2 into 2, that will be 2 to the power q. 9 equal to 3 into 3, that is equal to 3 square. 25, that is equal to 5 into 5, that will be 5 square. No common factor other than 1, so HCF will be 1. 8, 9 and 25 consist 2, 3, 5 as a prime numbers. So after taking maximum power of each prime factors, LCM equal to 2 to the power q into 3 square into 5 square equal to 1800. Question 4. Given that HCF of 306 and 657, that is equal to 9, find LCM of 306 and 657. Solution. As we know by verification formula, HCF into LCM, that is equal to products of numbers. Now 9 into LCM, that is equal to 306 into 657. Now LCM, that is equal to 306 into 657 whole divided by 9, that is equal to 34 into 657, that will be 22338. Now next question 5. Check whether 6 to the power n can end with the digit 0 for any natural number n. Solution. If the number 6 to the power n ends with digit 0, then it should be divisible by 5. As we know, any number with unit place as 0 or 5 is divisible by 5. So prime factorization of 6 to the power n, that is equal to 2 into 3 to the power n. Therefore the prime factorization of 6 to the power n does not contain prime number 5. Hence it is clear that for any natural number n, 6 to the power n is not divisible by 5, and thus it proved that 6 to the power n cannot end with the digit 0 for any natural number n. Question 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. For this, we will give a solution by the definition of composite number. We know if a number is composite, then it means it has factors other than 1 and itself. Therefore, for the expression 7 into 11 into 13 plus 13, taking 13 as a common, we will get 13 into whole bracket 7 into 11 into 1 plus 1, that is equal to 13 into 77 plus 1, that is equal to 13 into 78, that is equal to 13 into 3 into 2 into 13. Hence 7 into 11 into 13 plus 13 is a composite number. Now 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Taking 5 as a common, we will get 5 whole bracket 7 into 6 into 4 into 3 into 2 into 1 plus 1, that is equal to 5 into 1008 plus 1, that is equal to 5 into 1009, and that hence 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Question 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Solution. Since both Sonia and Ravi move in the same direction and at the same time, the method to find the time when they will be meeting again at the starting point is LCM of 18 and 12. By prime factorization method, prime factor of 18 and 12 is 18 equal to 2 into 3 into 3, that is equal to 2 into 3 square, 12 equal to 2 into 2 into 3, that is equal to 2 square into 3. LCM multiplication of prime factor with highest power, that is equal to 2 to the power 3 into 3 to the power q, that is equal to 36. Since both Sonia and Ravi will be meeting again at the starting point after 36 minutes. Chapter 1, Exercise 1.2. Question 1. Prove that root 5 is a irrational number. Now proof. Let us assume root 5 is rational number. So root 5 can be expressed as p by q, where p and q are integers and q not equal to 0, such that p and q is prime. No common factor other than 1. Root 5 equal to p by q, 5 equal to p square by q square. Squaring both sides. Now p square equal to q square 5. Equation 1. P square equal to 5q square, that means p square is multiple of 5, which means p is also a multiple of 5. By fundamental theorem of arithmetic, let p equal to 5c. For some integer c, 5c square equal to q square 5. Substitute p equal to 5c in equation 1. Now q square equal to 5c square. After simplifying, this indicates that q square is multiple of 5, meaning q must also be multiple of 5. By fundamental theorem of arithmetic, since both p and q are divisible by 5, they share a common factor of 5. This contradicts the initial assumption that p and q are co-prime. Conclusion. The contradiction means the original assumption that root 5 is rational is false. Therefore, root 5 is irrational. Question 2. Proof that 3 plus 2 root 5 is irrational. Proof. Let us assume 3 plus 2 root 5 is rational. So 3 plus 2 root 5 can be expressed as p by q, where p and q are integers and q not equal to 0, such that p and q is prime, no common factor other than 1. Then therefore p by q minus 3 equal to 2 by root 5, p minus 3q divided by q, that equal to 2 root 5, that is equal to p minus 3q whole divided by 2q, that is equal to root 5. Since p and q are integers, we get p minus 3q whole divided by 2q is rational, so root 5 is rational, but this contradicts the fact that root 5 is irrational. This contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational, so we concluded that 3 plus 2 root 5 is irrational. Question 3. Prove the following are irrational. Now, first question is 1 by root 2. Let us assume that 1 by root 2 is rational. So, 1 by root 2 can be expressed as p by q, where p and q are integers and q not equal to 0, such that p and q is prime, no common factor other than 1. Therefore, p by q, that is equal to 1 by root 2. We can write q by p equal to root 2. Since p and q are integers, we get q by p is rational, so root 2 is rational. But it contradicts the fact that root 2 is irrational. This contradiction has arisen because of our incorrect assumption that 1 by root 2 is rational, so 1 by root 2 is irrational. Next question 2. 7 root 5. Let us assume that 7 root 5 is rational, so 7 root 5 can be expressed as p by q, where p and q are integers and q not equal to 0, such that p and q is prime, no common factor other than 1. Therefore, p by q equal to 7 root 5, that is equal to p by 7q equal to root 5. Since p and q are integers, we get p by 7q is rational, so root 5 is rational, but it contradicts the fact that root 5 is irrational. This contradiction has arisen because of our incorrect assumption that 7 root 5 is rational, so 7 root 5 is irrational. Now third, 6 plus root 2. Let's assume 6 plus root 2 is rational, so 6 plus root 2 can be expressed as p by q, where p and q are integers and q not equal to 0, such that p and q is prime, no common factor other than 1. Therefore, p by q, that is equal to 6 plus root 2. Now p by q minus 6, that is equal to root 2, that can be p minus 6q whole divided by q, that is equal to root 2. Since p and q are integers, we get p minus 6q whole divided by q is rational, so root 2 is rational, but it contradicts the fact that root 2 is irrational. This contradiction has arisen because of our incorrect assumption that 6 plus root 2 is rational, so 6 plus root 2 is irrational. Thanks for watching video. Like, share and subscribe please.